Now, we find it's possible to overcome those challenges. And there are two ways that we typically think about surmounting this obstacle. The first is model selection. And it turns out there are many, many models we could choose from when we're building machine learning tools for investing, and some are better than others. So neural networks are famous for being able to find structure in data to an arbitrary level of precision, but they depend on the data being less noisy. And if there's a lot of noise in the data, if there's a lot of randomness, they'll often fit to that noise. And then when you try to use the model to make predictions, after you've trained it, it doesn't work so well in the real world. There are other methods, and one of those that I'll talk about a little bit is something called tree-based models. And tree-based models are less susceptible to that type of overfitting, and they tend to work better in an application like finance. But the more important element of making machine learning work in financial markets is something that they refer to in the machine learning domain as feature engineering. And feature engineering is just recognizing that machine learning is about learning from data, but you have to input the data. We have to supply the machine with examples that it can learn from. And if we give it higher quality data, and importantly, if we give it data that has hints about where to go looking for structure and patterns, then the machine is going to be more effective at finding those. And so this is where there's a real place for humans in the process, is coming up with better data and then letting the machine sort out how to best use the data to make predictions. And this is something that's been recognized by users on that website Kaggle. The top contestants, including this Kaggle grandmaster, Sergey Jurgensen, who said that feature engineering is the art part of data science. They recognize that to win these contests, probably the greatest skill is actually in building the best features to make predictions. An even better quote, I think, comes from Andrew Ng at Stanford. So he's a professor of computer science, probably one of the most well-known researchers in machine learning. He was one of the founders of Google Brain, and he was actually, until recently, chief scientist at Baidu, which is China's answer to Google. He said that coming up with features is difficult, time-consuming. It's what requires expert knowledge. And so he's basically saying here that you need domain experts. You need Fan Hui to help the Google team build this AlphaGo model with the knowledge of an expert Go player. For our purposes, we need people who have financial knowledge, who can build good data to input to our machine learning. Andrew Ng said, applied machine learning is basically just feature engineering. So recognizing the importance of choosing the right model, recognizing the importance of coming up with the best inputs, it actually creates a lot of scope for humans to play an important role in this process.